Hello everyone. Today we are going to diagnose this Honda EA6. This vehicle fails to power up due to a high voltage interlock fault. First, let's attempt to power on the vehicle. As you can see, there is no power up indicator. Now we will use diagnostic equipment for testing. Let's check what fault codes are present. First, let's perform a full system scan. The repair shop stated it was a high voltage interlock fault. They have already inspected the vehicle, but found no obvious issues. Let's check the diagnostic report. As shown in the report these fault codes: high voltage interlock circuit hard wiring anomaly and high voltage interlock circuit anomaly. Now we will access the vehicle control module, then read the data stream to roughly locate the fault point. We can directly search for the required data stream. It can be seen that the high voltage interlock circuit is abnormal. The BMS high voltage interlock circuit status is also off. For the HCU vehicle controller, the digital output status of the high voltage interlock circuit is active. Based on this data stream, we will go inside the cabin to inspect the wiring. From the fault codes we read earlier, we will inspect according to the wiring diagram. As you can see, this gray wire is the high voltage interlock output wire. First, let's check these connection points. The first is the high voltage interlock connector at the power distribution box. Then, it is connected in series to the compressor, which also has a high voltage interlock connector. Then, to the battery heater and the warm air heater, which also has a high voltage interlock connector. The entire high voltage circuit then loops back to the vehicle controller. Now we will check the voltage of the high voltage interlock connector at the PDU. The wire from the VCU to the PDU. Let's first measure the voltage. The voltage is 11.6 V. This wire has power. Now let's measure the second wire. We have connected the meter. There is no voltage on the second wire. From the inspection above, we can determine that there is an internal fault in the power distribution box. Now we need to remove the cover of the power distribution box for internal inspection. First, we disconnect the negative terminal of the low voltage battery. Next, we use an 8mm wrench or socket to remove the bolts. After removing the cover, now we will measure using a multimeter. From the high voltage interlock connector, we found one wire with 12 V power and one wire with no power. We will start checking from this connector. We press the interlock switch on the upper cover and measure the resistance here. After measurement, we find the circuit is open. Our inspection found the pins in the high voltage interlock plug backed out during handling, causing the HV interlock fault. You can see one terminal is missing. We have now reinstalled the pushback terminal and reconnected the connector. We plug the connector back in. We measure the resistance again. As you can see, the circuit is now closed. The interlock switch on the upper cover is pressed down. The multimeter shows continuity. We have now reinstalled the cover. We can reconnect the negative battery terminal. We can perform a diagnosis using the scanner. The vehicle has powered up successfully. Now we will diagnose the fault codes again to check if the interlock fault still exists. First, we clear the fault codes. The interlock fault code no longer appears. To ensure everything is normal, we will read the data stream again. Now the high voltage interlock circuit status shows normal. Therefore, the fault has been resolved.